delighted to present to you today a day in the life of a maintainer. My name's Jordan Walters. I'm a predictive maintenance engineer with Siemens, and I'm joined today by Sam Maxwell, who's going to introduce himself now.
So yeah, hi, I'm Sam. I'm a digitalization engineer with Siemens Congleton, the drives manufacturer in Cheshire. I work on digital projects and digital technologies for Congleton, and I was the person responsible on site for the implementation of Senseye Predictive Maintenance.
Excellent, yeah, thanks Sam. Well, we're here today to talk about, of course, the day in the life of a maintainer, but specifically our implementation of Senseye Predictive Maintenance at the Congleton site. Mm-hmm. So I thought maybe we could take this from the very top when we first started out with you guys. So when we began, we started off with just a bit of a data analysis, didn't we? Mm-hmm. Try and do a bit of asset selection, so we can determine what would be the best asset. I don't know if you want to make some comments on the initial kind of shortlisting of those.
Mm-hmm. Absolutely, yeah. So as a site, I suppose a bit of context is useful. So we make variable speed drives, as I said before, and we do an end-to-end process for that. So we do PCB manufacture, although we get the bare boards in, and we do final assembly as well. So lots of screws, lots of housings, that kind of thing. So there's quite a few different assets to look at, and we did an appraisal across the factory of what we felt was going to give us the best ROI in terms of the need for availability, the need for reliability, and the general maintenance effort involved in keeping a machine. And there's quite a few different assets that would spring to mind. So we have pick and place machines, which is something we discussed.
Yeah, I certainly like the look of those. When I came to the factory, thought they were very interested in looking at all the spools, feeding everything in.
Yeah, pretty cool seeing how fast they run, isn't it? Yeah. And they take quite a high maintenance effort. But actually the machine we landed on, as we know, is the wave solder system. So we have 3 wave solder systems on site for 3 different lines. And to sort of give a basic description of the machine, what happens is a board comes through on a tray, and there's effectively kind of like a wave of molten solder, hence the name, underneath, and the board passes over that, and that solders all of your through-hole components to the board. And the issue with these machines is that they're extremely powerful, very quick for manufacturing process, but there's loads of parameters in there that you have to tune and maintain and manage. So the height of the wave, the temperature inside the chamber, all these things really matter in terms of providing quality. And of course, that's the ultimate goal for the factory, is to produce the most amount of stuff at the highest quality we can, at 100% quality. So in the end, me and you spent quite a bit of time, didn't we?
We did.
Going through these BDE files.
Yeah, they were huge, right? All the parameters you're talking about, they get set based on which program we're looking at. There's hundreds of these, right? I remember at least looking myself for about 100 different columns plus.
Yeah, we're talking like 200 plus, I think. And obviously not all of them are relevant for what we're doing, but me and you spent quite a bit of our effort, didn't we? Understanding what the columns meant and how the machine actually produced that number, and then also trying to understand actually what was of value in terms of a predictor. So is this something that actually gives us an early warning of a problem, or actually is this just kind of in the moment and therefore useful but not as useful for prediction?
Exactly. Yeah, we were trying to find some condition indicators, so that we could see, what changes across the, board production, and not just, a fixed value like set points. We're not really very interested in those, and that makes up a good amount of the measures in there, because of course a lot is about meeting those set points. Mm-hmm.
And I think this is a really important thing that we've landed on in the time, isn't it? Is that actually investing a lot of time and effort into that early stage of understanding your data that's coming out of the machine, how it's produced, and which points you want to log.
Yeah.
Actually, that pays dividends tenfold down the line, because we know that we're operating off some really solid information.
Whereas not 200 plus.
Yeah, not trying to sort of 200 plus.
If somebody looks through those, they're not going to have any idea what's going on in there. Yeah.
Exactly. It might have made the graphs a little bit busy at the end. Yeah. Exactly that. Yeah. So that's been a real learning point for us, and obviously you did the work as well to calculate the offsets. I don't know whether you want to quickly talk through that.
Yeah, sure. Yeah. So I mean, obviously, when I was looking through initially, we've got these 200 plus different variables in there. So a good bit of my time was spent kind of determining, which of these are important. So in doing that, I took out a lot of constants. But then, of course, as I came to look through the whole 200 columns, realized that a lot of those constants are those set points, which quite clearly a lot of the time when we're looking at machines like this, and we see this in other assets as well, we're interested in the machine's ability to meet those set points rather than just say a fixed value, because if we're changing all the time anyway across programs, it's not a great indication of what's going on. It's helpful, but it's not necessarily the best. So looking through all of those columns, we found there's a lot of different set points. So actually, as you know, how when we're monitoring these things, a lot of it's done based on the offset values rather than those fixed values. That's not to say actually that we don't also monitor some thresholds based on the real values, because of course the magnitude of that data is important.
Yeah, I think it's been an interesting one to see the power of the platform in terms of being able to calculate those offsets. So we're passing up that set point value and we're passing up the real-time value, and then you guys can just calculate it off the bat, which again really helps us because we're not having to kind of implement that logic at a low level, particularly when we don't have that kind of capability yet. So actually that's been really helpful.
Yeah, it helps take away some more of that pre-processing legwork and makes it more both manageable and understandable, I think, within the app, because we can run that through our derived measure functionality, which, when you understand how that is set up, it's just, some block inputs and block outputs. Very easy for anyone to pick up, really, and once you're used to it anyway, and make new, more complex derived measures out of those. But ours is very simple at the moment. We've got that raw measure coming in from you guys for both the set point and the actual points, and then we just calculate those in-app for, the maintainers also to look at and make any adjustments as needed.
Exactly, yeah. And I think the real benefit for us as a factory is that, me and you have had conversations, and you're also now having conversations with our maintenance department, which we can talk about a bit later.
Yeah,
but
of course, yeah.
That ability to just tweak it on the fly as we discover how the machine's going to react is really useful as well. And I suppose that kind of probably segues into quite a nice next point, is about the actual process experts themselves, because that's been a really important part for us as well. And I know me and you at the time were really keen to get people involved as early as possible. So we had some of our site process engineers involved in initial conversations around what data points they thought were useful based on their kind of intuitive knowledge of the machines and having worked with them for many years, and also some of our site maintenance engineers as well doing the same things. And actually a close collaboration with them from the beginning has been super useful for me and you, because
definitely.
I can look to identify, okay, is there a problem in the pipeline somewhere, which means we're not getting the data that we think we should be, and for you it's kind of, okay, we've had this error, what does that mean in practice?
Exactly.
Which again is super important, isn't it? I don't know whether you want to shed any more light on that.
Yeah, well, I mean, I wanted to, kind of give a shout out to Tom when we came for the visit, who who took us around the machines and showed us them in detail of actually how it works. Because it's one thing being provided with a huge data set, right? As a lot of the data analysis work we do, we're familiar with a lot of different data sets. But when you just have a list of numbers, almost, it's quite abstract, right? Like it's not quite, not necessarily clear straight away what it is that this is referring to. When you're there in person being shown the machines, and you're like, okay, well, I know that these columns here relating to, like your temperatures for the like convection zones and things like this relate exactly to this machine right here. It all of a sudden starts making a lot more sense. So when you see these deviations, it's not just, almost like a data science task, right? It's an actual practical machine in front of you that you can link these issues to. And that's why we need the experts.
Exactly, yeah. It makes it real for you, doesn't it? I think in a way that just sitting and looking at the data can never do, really. I think seeing the machines always really, really important. And even those small things operationally, the way solder systems have panels over the top of them that they open up.
Yes.
And so one of the measures we look at is the O2 in the atmosphere, isn't it? But of course, when they open the door, that drops.
Yeah,
so we're looking at that in the data set thinking, oh, something's gone really wrong, but actually no, it's fine.
That was definitely an interesting one to see walking around, and you see that obviously it's an active site. You know, it's actively producing these products, so people are going to obviously be actively maintaining those. So when you see those, it's nice to know that okay, there is actually something going on here that's expected, as opposed to something that's going on here that's really not expected, and we're seeing, you know, a leak or something out in that atmosphere, which would be obviously a lot more concerning.
Yeah, exactly, and I think it's beneficial twofold in that if you have a real problem, as you say, you can identify it and you can look to fix that, and as the platform learns those behaviours, it'll give you early warning on whether there's going to be a problem or not. And the flip side of that is that actually we can verify their intuitive knowledge and understanding by looking at the data set that we get out. So you know, a lot of our process engineers, they know the machines very intimately, and we can actually sort of combine that knowledge with the graph and say, okay, actually this data set does say what you're saying as well, which is really good. It kind of gives you confidence in that, you know, in those things that you've been using as rules earlier on in manufacturing, you know, to kind of say, okay, yeah, this is actually backed by the data that we're getting from the machine. So that's been super valuable as well.
Yeah, I think that's a super important point too. Almost like when you look at the way that Senseye Predictive Maintenance works, you know, it almost is having that just like raw data view. That's how the app looks at things, right? It doesn't understand necessarily what it's looking at because it's so versatile. It can be applied to any type of asset that is just looking at this from, you know, deviations from the norm. So you need the experts to weigh in here and say, right, that's what this deviation is actually referring to, so that the system can then learn that as well, because, you know, it's not an expert on every single type of asset, right? It's a generalist, really.
So I know once we'd kind of defined our data points and we'd gone through the table and understood what we thought was going to be valuable, it was then about the data pipeline, wasn't it? So we should probably sort of have a quick discussion about that. But the pipeline we're using is these machines are a bit older, so this file-based system, and so we share that file via the network, and then that's ingested into AWS, where Senseye Predictive Maintenance picks it up from the SQL database. And obviously there's the usual challenges with that kind of pipeline in terms of networking. Obviously cybersecurity is a really, really key one, and we put a lot of effort into ensuring that the system was secure, and a thanks to our colleagues in our German partner factories as well for their help with that, in terms of giving us a sort of framework for a similar system that they've done. And so yeah, there's all that effort in terms of making things secure and making things robust and reliable. I think that's one really important point to make is, you know, you're looking for the reliability of the machine and availability of the machine, and the same is true for the pipeline as well, as it were.
If we lose that pipeline and we're looking for, you know, an issue on the machine which may only give us a day lead time to fix it, and the connectivity's been down for a day, you know, it's a nightmare basically, right? So we've got to make sure that is a robust pipeline, and I think we've succeeded quite a lot on that front.
Yeah, exactly, and you know, again, a thanks to our colleagues in DIIT and over our partner factories in Germany for helping with that, because they've been a big hand there as well, in terms of getting that pipeline set up and helping us configure it. And as you say, for these kind of predictive maintenance applications and these machine learning applications in general, a consistent, you know, pipeline of information that these algorithms can train on is really, really important. So, you know, the robustness of that foundation's really, really key. You know, if that's not solid, then whatever you build on top's going to struggle a little bit. Yeah, exactly. Yeah. So that was kind of step 2, wasn't it? We did the machine and the data pipeline connection, and then after that, we actually had the data in the platform. Okay, so that was step 2, and once we kind of finished this data pipeline, the data was then actually in the application, and then it was a collaboration between me and you, and also then our process engineers, as we've discussed earlier, to actually set up the predictive maintenance. So I don't know whether you want to kind of elaborate on that.
Yeah, I think that's probably a good idea. So yeah, of course, once we had all the data into the app, then, you know, it's on me to start getting everything configured as, you know, the delivery person on the job. So I went through and I set up lots of different things. So for example, like the configuration groups, the drive measures, thresholds, and all things like this. And what this has let us do recently, because in the past this was each machine had to be configured independently. Now we have these groupings, which our back-end team and product team have set up, which has been a blessing, because it means that we all just have to do this task once, and we can apply that to every single one of these assets coming online. So of course, as you mentioned, there's 3 different wave soldering machines. There's going to be small differences between them, and we can tweak those and configure those parameters as and when. But generally, they're all wave soldering machines. So they're going to share a lot of very similar parameters. So it just allowed me to go in there, talk with the process guys, figure out what kind of characteristics that needs to be set there to actually configure these in the app to be presented as a wave soldering machine. And I think the other important thing to bring up here as well is the fact that we actually, wave soldering machine's one asset, but we split this up into 3 different sections and 4 when it comes to the eco line. But maybe you want to elaborate more on that one separately.
Yes, yeah. So we have the different assets, don't we, within the machine, and that is really down to actually the different functions of core sections of the machine and how they operate. So one example is the solder bath for the machine, which is actually the kind of the pool of molten solder that's then pushed up into a wave. And that has a set of attributes and parameters associated with it, but then we also have a separate thing for the conveyor. And the point you made to me at the time was actually if we segment these out into different key blocks, we can monitor them separately. And that actually means that also the alert you're getting is more specific. So you're not getting alerts saying, there's something wrong with the wave solder system.
Yeah, which is like, okay, right, well, what's wrong then?
Yeah.
Lots more investigation required.
So it's a bit like saying there's something wrong with your ship. It's like...
Yeah, it's not very helpful.
Yeah.
It could be anything.
Yeah, exactly. So for our maintenance engineers, it's actually really important to have a bit more of a granular view. And so actually by splitting it down, we get these alerts based on the conveyor or the solder bath or the actual atmosphere and the preheaters. Yes, and the preheaters as well. Yeah, so there was that segmentation that we did. And I know as well you've done some tuning for each.
Yeah, under the hood as well. Of course, as we're using the app and the maintainers are using the app, they can provide feedback based on those detections, which is already going to push the algorithm in the right way because, of course, when it's learning to begin with, it's just good. It doesn't know what you're interested in, right? If it sees an anomaly appear, it's going to say, okay, there's an anomaly here, but you might not be interested in a deviation of, say a magnitude of 1 or 2. It might be in the hundreds you're looking at, or depending on the scale, it might be more milli scale that you're looking at rather than, say tens or hundreds. So providing that feedback helps, but then also I can do some individual tweaking under the hood for some more parameters just to fix, like a couple of issues where it might not hit certain detections that we do want it to, as opposed to certain detections that we don't want to hit it on. So for example, we had a detection recently, which was on the preheaters, I believe.
Yes,
and
that's right. Yeah.
With that one, it was we plotted that out after it came through because the system didn't quite pick it up, which was quite confusing because obviously you see a lot of you see the spike and you're like, okay, I can see that being a detection, but when you compare it to the other data within that set, it's very, very fine.
It looks normal.
Yeah. To the machine, it looks normal because it's getting these spikes constantly, and this one was just a little bit more so than the rest of the data set. So I had a bit of investigation into that, played about with some of the parameters in our back end, and I found that if I adjusted just a couple of those parameters, obviously I won't go into detail as to which they were, but adjusting a couple of those just a tiny bit meant that we hit that detection without constantly getting triggered by all the noise that we already had there. And it just shows some of that fine tuning that we can do once we have that understanding of the system, an understanding of the assets, and kind of combine those,
Exactly, and I remember you showing me the graph showing, okay, here's the before and we're not detecting here and here, and then here's the after, and we're not detecting on these peaks that were normal, but we are detecting here on this peak that actually we had then had an issue off the back of. So again, there is that ability to turn some dials and actually really fine tune on even slight changes in the way your data's moving as there's an issue, as opposed to when there's just a nominal kind of interaction with the machine that occurs. So that example we gave earlier of them opening the hood. Exactly.
Yeah.
You don't want to trigger on that, but then if the O2 drops off for some other reason, like a leak, you want to trigger on that. But actually, the two in the data might look very similar. So you need to be able to really tune in on the fine differences. And I think one, again, thing to really come back to at that point, which is what we started our conversation with, is that interface with the maintenance engineers, the process engineers, and understanding their innate knowledge of the machine.
Exactly.
And I know you've been, a shout out to Andy from our maintenance department, who's been collaborating with you really closely, and that's been really helpful interaction for you, hasn't it? Because he can give his knowledge and understanding of the machine from many years of working with it, and it means you can tune those parameters in exactly to when he's saying, oh, that's a real issue, we need that detected. Oh, actually no, that's nothing, that's something, I went down and did this, I went down and did that. And the ability to tune in on that's really, really powerful. And I think also you need their feedback generally in terms of, is it alerting them in the right way? Is it early enough, or actually, was it kind of too late for them, and they're on some of the maintenance job, and it's the practicalities of the system, isn't it, as well,
fitting in with their day-to-day.
That are really, really important. And again, I think that comes all the way back to that initial investigation of which data points we were looking at. And again, that solid foundation then gives you this ability to, say, tune and tweak things so that you can really accurately diagnose, okay, yeah, that was a problem, that wasn't, that kind of thing.
Yeah, and I mean, I think the communication, like you say, between our side and your side team side is super, super valuable. And you guys have been great with it, with like the back and forth, where it's like there's a real dialogue going on there. Mm-hmm. If there's an issue, it's not like well, we don't want to anger these guys by saying there's a problem. It's okay, this is what's going on, and we work together to fix the issues that prop up, which is exactly what the journey should be like. Mm-hmm. Because if one side doesn't want to say something, nothing's going to improve and nothing's going to get fixed. We get the best end result by having that clear communication between both sides.
Exactly.
So definitely, even with Andy, like, it's been great having these fortnightly meetings with him, because he jumps on, tells me exactly what he's been looking at. He deals with the cases straight away. We actually updated the notifications the other week so that he gets those as the cases are raised. Because typically I'd usually recommend they come through, on the morning, but sometimes, well, in a couple of these cases, something's popped up halfway through the day, and then he doesn't get notified about it until the next day. So having those come through straight away, just refining it to what specifically works for him, it is the way to go, because it means that, again, like you say, it fits in with the workflow, and it's not like, we have to come and jump on the platform. It's okay, this is helping me, this is a tool which is assisting me in what I'm going to be doing anyway.
Exactly, and that adoption topic is super, super important. We've focused on the technicals here quite a bit and the interaction with them in a technical aspect, but actually what comes along with that by bringing them on the journey from the beginning is their adoption of the platform is far easier, because they can take ownership of it from an early stage.
Exactly.
Which, again, as you say, it then means it becomes part of the process for them, and it becomes a tool in their belt that they can use to help run the factory at high availability, high quality. Whereas if you kind of set it up and then chuck it over the wall, as it were, it lands on them and they go, oh, what are we supposed to do with this? So again, it's that continuous dialogue, and it's bringing them along from an early stage, and answering questions is a really important one in terms of, how does the platform work? A lot of people want to know the ins and outs of, okay, what's it detecting? How are you tuning or tweaking that? I know Andy's been talking to you about those kinds of things.
Yeah.
And then things at the other end of the scale in terms of normal operating things, like the scheduled downtime was something we had a discussion about recently. And
of course, with the new year, being able to put that in, and we just had that conversation with you guys, and specifically Andy, to put that in so that it turns the analytics off essentially for that period of time where the machine's going to be down, because of course you don't want the platform to be learning that the machine being off is normal, because
exactly
it's not very useful.
We're shutting down to save energy, to save cost over that Christmas New Year period, and as a result you're getting totally different data from the platform. So the best case there is that you come back in and you've got 100 emails from the platform saying there's something wrong.
Exactly.
Of course
it's concerning, right? If you return from the new year,
everything's flatlined.
Everything's turned off.
But of course, the reality is that we've turned everything off, and actually, you're absolutely right. What you also don't want is it to learn that that's normal behavior, because of course for us it's not. For us, operational behavior is the normal behavior, and it may go into standby on and off, but it's never going to be fully shut down normally. So we don't really want it to learn on that erroneous data that you're getting from when you've turned it off fully. So yeah, that's been a really important one as well. That dialogue with him and with our process engineers, just to understand those small operational topics, which actually have a massive impact then on the performance of the predictive maintenance as well. So yeah, that dialogue I think is key. I think we've both really learned that, haven't we?
Oh yeah, 100%. Night and day when the teams are very active in communicating what's working and what isn't working for them. Because I think as well, when we have defaults set up, to say like, okay, this is generally how people work. Of course, not everybody works like the general way, right? So being able to tweak those for what works for other people in certain teams means that, they're going to be far more likely to really get involved and want to use the tool. And then once they're using the tool, then, they're going to see how useful it can be with predicting these things.
Exactly, and ultimately you want it to be part of their process, as we've said. So you want it to be something that they turn to in order to get answers about the equipment. And I've said to them even so much as, okay, they may have run into an issue, and then it's actually, look, you've got the graphs of the data before that issue occurred. Does that give you some indication as to what the problem is with the machine? Because it's like taking your car into the mechanic. They can't look at the outside of your car and go, oh yeah, it's definitely going to be that.
Yeah.
They need context, they need understanding of the symptoms of the problem, and of course the data, the graphs that we're getting from the platform is also all about that. It gives you these symptoms of, okay, what's the issue? And of course they've got a lot of knowledge that they've built up over many years and they've seen things before. But again, with newer equipment, there might be different issues that we've never encountered before. And even with older equipment, as it ages and wears, its behavior will change. It perhaps wants to operate at slightly different nominal parameters.
Yeah.
And you also have to think about new products that come in. We might be using the same equipment to run newer products, and they will need different operational parameters for the wave solar system, different temperatures, different wave heights, all these things. And again, learning how that machine is going to react to that new setup, or inversely how the product reacts to that going through that machine, is really, really important in order to get that quality up to 99-100% as soon as possible. And actually, again, having that data there ready, available anytime is, again, just super beneficial in that side as well, so they can see exactly what's going on from the get-go, rather than having to kind of download hundreds of pages of logs and then
trying
put
to
them in a spreadsheet.
and
it becomes a nightmare. So
I'd be hoping that the tools that we have within the app would really help with that analysis, right? Because this, as you've seen, you can manipulate like the different axes, blow up the graphs so we can actually see what's going on in more depth. Compare those, quite importantly, to other assets that are very similar. So I know we've only got the one machine that's or the one wave soldering machine, which is being monitored right now, but we're very close to having the other ones online as well, which is going to provide that standard for this is what we're looking at across all the machines. And we've got this other one that's working at a far different pace or parameters to the others, what's going on there, and it's going to just give a bit more insight into what's going on.
Exactly, yeah. It gives you insight into the behaviour of the machines, and also one benefit that we've already started to explore is, okay, if we've got similar equipment across different factories, you can actually see, okay, maybe for the same product in a different site, what are the parameters? How do they differ? Are there kind of environmental or process reasons for why parameters will be different? And also it means that it's an avenue to allow your maintenance engineers to share knowledge about the machinery, the platforms that they're trying to maintain, because chances are another site may have seen this issue before, and classically you may not know that. You're kind of operating on your own. But actually with something like this, you can send them a screenshot or something and say, have you ever seen anything look like this before? And they might say no, but actually if they have, then there's your answer. You can kind of it actually fosters a dialogue as well within the departments as well, which is really important. It's something that they can use to kind of have conversations around.
I mean, interesting point actually that you bring up, because one of the things that we're developing in the next cycle of the app is case conversations within those within the raised cases. So it means that the different maintainers that come in and take a look at what's going on, they can provide their feedback in almost like a bit of a conversation, right? So they can come in and say, okay, well, I've looked at this, it might be this thing. I've looked at this, it could be this thing, and it means that like you say, between sites or between lines, they can come and look at these and go, oh right, okay, so this is the dialogue that's been going on, rather than a quick footnote of, oh yeah, okay, specific problem or general solution, like 1 or 2 lines, which is quite tempting to write in the current kind of framework, right? But having it as more of a conversation gives a lot more context to what's going on and understanding for future assets to potentially catch those earlier too.
And one thing we discussed is maintenance management systems and integrations there as well, which of course, if you've got Senseye Predictive Maintenance sat there and they're entering information into that platform to say, okay, well, this case was caused by this and we've remedied it through replacing this part or cleaning this, etc. Actually, with an integration into your maintenance management system, you can then log that data in there, and that becomes effectively like a glossary for what happened when things went wrong previously, which again is super useful tool if you've got new people coming into departments or you're trying to train up apprentices or those kinds of knowledge transfer topics. Again, it's a book of information that says, okay, well, this is what we found in the past. And even if you've got new equipment coming in, chances are, if it's performing a similar job, it will exhibit similar, behaviors. Yeah. So actually, okay, older equipment, it might not be a complete analog, but it's going to give you an idea of how this newer piece of equipment might occur. Or the fact that you can then kind of look back and say, well, actually, we've not experienced this problem anymore. So something's fundamentally changed about the way this works, which means we're not seeing that any further, which is also really beneficial. So building up that knowledge and having a platform to access it and for them to review it's also really, really important one as well.
And that integration with the CMMS, it is going to mean that it's very seamless in terms of the guys working with it. It's not like they have to go between lots of different databases and platforms to be able to say, okay, this happened, and it's like, okay, where's all the information? It's all going to be together in one place, and that's going to help also record a lot of the KPIs, because I know you mentioned a lot about the availability of the machines being one of the most important topics. So of course, we want to know how we're helping we can see that keep the availability up.
And again, that comes back to your process discussion, doesn't it? Right, because we want them to have this as part of their core process, and actually, for a maintenance engineer, they're getting called repeatedly, different things, that they might need to attend to, and so typing lots of information into multiple platforms and repeating themselves is a waste of time. Yeah, it's not viable. So actually having these integrations is super important as well, because they can put it in one place. It's a single source of truth for what they're doing, and it means that all that information they can collate in a central platform, and then they can actually, when they've got the time further down the line, they can review and say, okay, well actually that was the kind of biggest offender, as it were, this year, which is something that our maintenance department does in trying to understand, okay, what was the problem or the symptom that actually kind of occurred the most.
Yeah, and what are the areas of focus, right?
And that allows you to kind of lean into your preventative maintenance, and that's something that me and you have discussed in terms of the ROI.
Yeah,
is actually saying, okay, well, we've got the predictive element of this, and it tells us when things are likely to go wrong. But the major benefit of that for us as a factory is actually it gives us the confidence to possibly actually extend some of those maintenance windows. So at the moment, we're doing preventative maintenance to say, okay, we're going to clean this every couple of weeks in order to maintain normal operation. And that window might be decided based on intuition or by the manufacturer's kind of recommended guidelines or whatever it is. And there'll be a lot of information behind that. But actually the platform also gives you a confidence to say, okay, well, we're seeing a change in nominal values over 2 weeks. Okay, maybe 2 week period's right. Or inversely, we're saying, actually, this looks pretty good over a 2 week period. So if we extend it out to a 3 or 4 week period,
then it will still be operating.
It should be okay. Yeah. So actually it means we're visiting that machine less, And ultimately, we're not spending as much maintenance time, as much maintenance cost operating that particular piece of equipment. We can devote that resource elsewhere. So it's also an ROI in terms of reducing the amount of time we have to attend to each piece of equipment as well.
Yeah, well, it's quite similar to what I was saying before with the Senseye Predictive Maintenance setup. It comes as, there's some default values, but that doesn't necessarily mean they're the best values. And that's where that refinement comes on, and how Senseye Predictive Maintenance can help refine the machine's maintenance, right? Even, not as even just like a detection that we say, okay, something's going wrong now, but generally over the lifetime of operation, we can say, okay, yeah, let's try and narrow that window that we need to perform the maintenance, or let's expand it so that we don't need to have somebody on the machine every 2 weeks. We can do it maybe every month.
Exactly, yeah, exactly. And I suppose that brings us towards, okay, where next, right? So we've kind of done this for the wave solder systems, and we've proven that that's very useful. We've had detections. We had the convection fan very early on, actually.
Yeah. That was almost as soon as the learning period was over, we got a detection, which sometimes is a little bit concerning. But in this case, it was actually quite good to see, because it was, straight away we got some nice proof that what we've set up is set up.
Things
nice
are functioning.
Correctly. It's functioning as it should be. And we got our first success case on that convection fan. But the interesting thing is as well, since then, I've been having conversations with Andy, and he's been telling me that he's seen a few more anomalies from the convection fans. And to begin with, he thought that it was just like a few small blips, not massively associated with anything. But after our meeting this week, actually, he mentioned that it's looking like we might have had a dodgy batch of fans come in.
Right. Okay. Wow. Okay.
Yeah.
Really interesting.
So
okay.
he's keeping a strong eye on that one, and whenever these anomalies are popping up, which before might have been ignored, because Senseye's picking these up, we're seeing that there's actual something happening. So yeah, it's quite nice to see that we've actually got some tangible results coming already, considering the relatively small amount of time we've been operating for.
Evidence of perhaps a deeper issue that then they can actually look at solving in the long term, which again,
exactly,
all the root of that is that then if perhaps we have got a bad batch of fans, or they need to sort of change that part, then if they do that, their internals are reducing the amount of time in the future that they've got to tend to that machine. They're not having to constantly go back and fix that same problem over and over again, which is really important. And that's really for the future where we want that process to be. We want them to be able to use it as a tool, so they're reducing the amount of time they have to interact with the equipment where possible.
Yeah.
Obviously, you're always going to have your regular preventative maintenance. That forms part of the way the factory runs, and maintaining quality and all those really, really important things. And I think for us the future is looking to scale across some of these other pieces of equipment that are very high availability and also quite high risk in terms of performance and output. So we talked about the pick and place machines earlier, and they're a fantastic example because they're right at the start and right at the heart of the factory, and they feed all the upstream processes. So you need those running as much as you possibly can, because if they're not,
it's affecting
things stop further down the line. So actually, really, really good use case and example. And also, they're very complex machines. So natively understanding how does that machine work, what influences it being available or not, what influences performance, can be very difficult to keep in your head without a lot of experience. So instead, having a platform that's tracking all that information for you and making predictions, super valuable again. So I think those kinds of directions. We've got other examples, test equipment, where that might be really valuable, where you've got a lot of different, perhaps even consumable parts that you need to replace on a semi-regular basis.
Yeah.
Those sorts of things are also really important. And again, there's ROI in saying, actually, we don't need to replace these pins as often as we thought we did, because they last longer than we thought we did based on this evidence. So that I think is the future for it, really, in terms of scaling, and also just really focusing on those areas where we can say, actually, we can claim a lot of benefit here by changing our regular processes on this piece of equipment, because we actually have evidence, so we don't need to tend to it as much as we thought we did.
Yeah, exactly. And we've got quite a few pick and place machines, right?
Yeah, quite a few. You're challenging me to remember the number off the top of my head, but there's at least 10, 12
Yeah,
I'm sure some people from the factory will be will be grimacing now. I don't know the number, but yeah.
Well, I think that's a great example, right? That we can get the setup for one of these machines, and then that's going to scale to the other, 10, 12, however many more.
Pass it across the rest.
And yeah, like I say, great opportunity to scale everything.
Yeah. Looking forward to the future. See how we go, and hopefully more machines to come, more interesting data, and we can kind of delve into what that means for the factory and what that means for performance of the equipment, and ultimately it's just interesting to see. Yeah, actually, it's doing what we think it's doing.
Well, that's the ideal outcome, right? Is that we're going to look at it and say, okay, we've got no detections, we've got no cases, things are working exactly.
That would be lovely.
I want them to work, and there's no problems. But that's why it's always good to have some software to back you up and say, okay, you can be confident in that, or okay, we do need to come and take a look at these things.
Something to base your thinking off of, exactly.
Yeah, precisely.
Brilliant.
All right, thank you for joining us, Sam. It's been a pleasure to have you on for talking about life of a maintainer and how Senseye Predictive Maintenance has helped you.
Yeah, always a pleasure, Jordan, to come and talk. I know it's been great collaborating thus far, and we'll see how we get on down the line. I'm looking forward to collaborating further, introducing some new machines, and ultimately providing some more benefit for our maintenance engineers, and seeing where new features of the platform go, and how we can make use of those down the line again to provide benefit for the factory ultimately.
Of course, yeah, I'm very excited to see how we scale, and it's always a pleasure working with you, so I'm more than happy to continue doing that in the future. Okay, thanks for joining us, and please check out our website for more information on Senseye Predictive Maintenance.